Hello and welcome. So in this video, we're going to look at matrices. And so some of the topics that I am going to go over are, we're going to look at basic matrices, we're going to look at scalar multiplication, we're going to look at adding and subtracting matrices, we're going to look at matrices multiplication, or determinants. And inside the description of this video, there will be chapters of where each of these sections will start. And so you're more than welcome to jump to that spot if you would like to just look at a specific section, or if you're wanting to see them all, then you're more than welcome to. And you're also more than welcome to take notes off these or write down these examples if you please. So for basic matrices, a matrices is just a regular array of numbers, a rectangle with an array of numbers. And so a matrices goes by rows, by columns. So in this one, we have 5 rows and 3 columns. And then on the second one, we have 3 rows and 3 columns. Scalar multiplication. And so it's initially it's similar to when you were, let's say, in algebra, where you had, let's say, 3 and then x plus 2. And so you would distribute this 3 over to the x and the 2. And that's initially the same thing with the matrices. So if we had a number in a matrices, we would take this number and multiply it out to every number inside that matrices. And so we're initially doing the same thing, but inside this, you would just get 3x plus 6. So let's look at an example. So we have 3 times this matrices. And we're going to factor this 3, or distribute this 3 out into the matrices to give us our answer that we were looking for. So if we look at this matrices, we can distribute the 3 times 1. You would have 3 times negative 4, 3 times 3, and then we would go down to row 2, where we have 3 times negative 1, 3 times 3, and 3 times negative 1. If we were to plug those values into a calculator, or do the mental math in your head, you would get 3, negative 12, 9, negative 3, 9, and negative 3. And that would be your answer for this one. So now we're going to look at adding and subtracting matrices. And so when you're doing these ones, you're going to make sure that the dimension of each of the matrices are the same. So if you had a 2 by 1, and then you also had a 2 by 2, you would not be able to add and subtract those matrices. And so if you had a 2 by 2 and a 2 by 2, you would be good to add and subtract those matrices. So let's look at an example. We have this first matrix minus the second matrix. And so this first matrix is a 2 by 3, and the second one is also a 2 by 3. And so we're able to add and subtract these matrices. So in this case, we're going to subtract. And so I would write it out the long way. And so the first one, we're going 2 minus negative 7, 4 minus 33, 1 or 3 minus 1, and then 1 minus 4, 8 minus negative 19, and negative 1 minus 5. And when you add and subtract those, or when you subtract those values or add with double negatives, you would get 9, negative 29, 2, negative 3, 27, and negative 6. And that would be your answer. So now we're going to look at matrices multiplication. And so in this, where you're going to want to make sure that these inside column values, these inside C's, are the same. And then the outside values are your answer size. So you might see it as R times C, and then C times N or K. So as long as these two values in the middle are the same, they're able to multiply each other. And then your answer size, or your answer size of the matrices, would equal R times n. And I know I spelled that wrong, but that's not the point. And so that would give you the size of the matrices that you're looking for. And if you have these two C values and they're not the same, then they cannot be multiplied together. So in this example, we have a 3x3 or 3x2 matrix and a 2x2. Since these inner two numbers are the same, we can multiply this matrix, and our answer matrix would be 3x2. So I'm going to write out the long way first. So we're going to do row 1 by column 1. So it would be -1 times 1 plus 3 times 0. And that would be row 1 times column 1. So now we're going to do row 1 times column 2. So it would be -1 times 2 plus 3 times 7. And that would be row 1 times column 2. Now we're going to move down to row 2. So row 2 is 4 times 1 plus 4 or 5 times 0. And that would be row 2 times column 1. Then we're going to do row 2 times column 2. So 4 times 2 plus 5 times 7. So row 2 times column 2. Then now we're going to look at column 3, or row 3, excuse me. So we're going to go 0 times 1 plus 2 times 0. And then we'll have 0 times 2 plus 2 times 7. And that would be row 3 times column 1 and row 3 times column 2. And when you multiply these out or plug these into your calculator, you would find that your answer would be -1, 4, 0, 19, 43, 14. And that would be your answer. So now we're going to look at determinants. And so the easiest way possible, you could memorize this formula if you would like. The easiest way that I memorize this is I think of, remember how or it might just be me, or if it's you, then you can kind of relate, in where you would draw fishes stick fishes or fishies in school, where you're going down and up, down, curl, and then up, so you can draw a fish. We can initially do the same thing. So you go, it's A times Z, B times C, and there's your fish. And so you have A times D minus B times C. And so you can kind of use the fish shape to give you the answers or get the formula without memorizing which position is A and B and C and D. So let's look at some examples. So the first one, we have this matrix. And if we use the fish, we go 3 times -2 minus -1 times 4. So if we had +3 times -2 minus -1 times 4, and that's still in the same format as A times D minus B times C. And our determinant value would equal -2. For this other one, we're going to go, using the fish, we're going to go 1 times 4 minus -3 times 7. And that determinant value, if you plug this into your calculator, would give you -17. So now we're going to look at finding the inverse of these matrices. And so we're going to find the determinant first. So that little fish that we used a little bit ago, we're going to put that matrix, that determinant value over 1, and then we're going to switch the matrix around, and then we're going to distribute that 1 over determinant into that matrix. So let's look at an example. So we have this matrix first, and we want to make sure that we find the determinant first. So we have the -7, the 10, 8, and 2. If we do our fish, we get -7 times 2 minus 8 times -10. And when you plug that into your calculator, you get the determinant value of 66. So now we're going to put it over 1. So our determinant would be, so we know our determinant is 66, and so we're going to put it over 1, so we get 1/66. Now we're going to flip the matrix around. So we know that if we have this matrix, -7, the -10, and the 8, and the 2, we're going to switch the A and the D position. So if you look at it, you have the A, D, B, and C. We're going to flip the A in the D position. You'd get 2, 7, 8, and -10. And then we're going to flip the opposite signs on B and C. So our new matrix would be 2, -8, 10, 7. And now we're just going to multiply. We're going to go 1 over the 66. Multiplied into our new matrix, the 2, -8, 10, and 7. When you multiply this out to every value inside of it, like the scalar multiplication, you would get 2 66th, 10 66th, -8 66th, and 7 66th. And when you simplify, you would get the inverse matrix would equal 1/33, 5/33, -4/33, and the 7/66 change stays the same. And that would be your answer. For the next example, we have this one. And so we're going to do the same process we did before. So we're going to find the determinant first. So we have the matrix that we're given. We do our fish. We get 1 times 4 minus 2 times 3. And that would equal -2. Putting the determinant over 1, we would get 1 over -2. Flipping our matrix around. So we start with the 1, 3, 2, 4. We're going to flip the A in the D position. And then we're going to do opposite sign on B and C. So our new matrix would be 4, -3, -2, 1. And then we're finally just going to multiply this determinant into this inverse matrix. So we get 1, negative 1/2. And our new matrix, 4, negative 3, negative 2, and 1. And we distribute that out. We would get it equal to negative 2, 3/2, 1, and negative 1 over 2. And that would be our answer for this one. Now we're going to look at augmentative matrices. And so now we're going to get matrices that are, or equations. So if we had x plus y plus z equaling 1, we're going to have to turn this into a matrices. And so this very simple matrices would just be 1, 1, 1. We have the bar that is our equal sign, and then 1. And so we're going to start having to do these with some of the equations, where we're going to have to get them out of the equations like this and turn them and put them into a matrices where we can use operations, we can solve to get a specific value, or use word operations. Now we're going to take these examples with the augmented matrix and we're going to turn these into matrices. And so for this one on the left, we're going to turn this into a matrix, augmentative matrix. For this top row, we would have 2, 3, negative 5, the answer or the equal sign spot, and then 1. Next row, we would have 1, 1, negative 1, 2. Row 3, you would get 3, 2, 1, 8. And that would be your augmentative matrix. For our second one, any spot that is missed, you would replace it with the 0. So for example, in this case, for row 1, we would have for the x position 1. Our y position isn't there, so we put a 0 in place for it. And then z would be 5, the answer or the equal sign, and the 8. In row 2, you would get 2, 1, 6, 12. Row 3, we get 3, 4. Since there's no z in this, we would just go 0 and then 9. And so that would be our augmentative matrix for that equation, or for those equations. So now we're going to use Cramer's rule. And Cramer's rule uses equations where you will have them in an x column, a y column, and then an answer column. And I know later when we go over the determinant of a 3x3 or Cramer's 3x3, you can think of this as the x column, the y column, the z column, and the answer column. Or you can think of it as column A, column B, column C, and then column D. They're the same thing, it just depends on how you want to think of it as. Whichever is easier, I would do that. So now let's look at an example using the Cramer's rule. And so we're going to turn this into an augmented matrix. So we'll have negative 4, 3, our answer, or our equal sign area, and then 3, negative 3, 4, and negative 3. So you can think of it as your x column, your y column, and your answer column. Or if it's easier for you, your A column, your B column, and your C column, which is ever easiest. For these ones, we're only dealing with x's and y's and answer. I would stick with the x and y and answer. So we're first going to look at getting our determinant. So if we have our leading coefficients, where we have the 4, negative 3, 3, and 4, doing our fish, we would get negative 4 times 4 minus 3 times negative 3. And our determinant value would equal negative 7. Now to find the value of x, we're going to use columns answer, we're going to replace the x column for the answer column and then the y column. So we have our answer column, 3 and -3, and we're replacing the y, and we're keeping the y column. So 3 and 4. And do another determinant. We would get 3 times 4 minus 3 times -3. And we would get 21. And so if you remember, for x, it equals d of x over d. So our determinant was -7. So we found that d of x was 21, and our determinant was -7. So our x would equal -3. To find y, we're going to keep the x column and replace the y column with the answer column. So you get -4, -3, -3, and -3. Doing our fish, we get -4 times -3 minus 3 times -3, which would equal 21. And doing what we did before for the y would equal d of y over d, and 21 divided by -7 would still equal -3, and that would equal y. And we would write our final answer as an ordered pair. So our answer would be -3, -3. So for the next one, we're doing the same thing. And so we're going to use the same thing with the Cramer's rule. We're going to have our x, our y in our answer column, and we're just going to solve to the point where we have an ordered, we get an x value, we get a y value, and we have an ordered pair. So we write out our argumentative matrix first. So for row 1, we would have -2, -4, and then 10. And then on row 2, we would have 2, 2, -4. And so I'm going to label these again as the x, y, and the answer column. We're doing our determinant first. So we have our coefficients. So 2, -2, -4, 2, and 2. Doing our fish, we would get -2 times 2 minus -4 times 2, and that would equal 4. So to find x, like we said before, we're going to replace the x column for answer. So we would have our answer column 10 and -4, and we would keep the y column. So -4 and 2. Doing our fish, you get 10 times 2 minus -4 times -4, which would equal 4. And do what we did before for x equaling d of x over d. So we get 4 over 4, which is equal 1. So then we will do, to find y, we will keep the x column and replace y with the answer column. So we have the -2 and 2 in our answer column, 10 and -4. Doing our fish, we get -2 times -4 minus 10 times 2. And that would equal -12. And for y, it equals d of y over d. And so -12 divided by 4, y would equal -3. And write our answer as an ordered pair. So our answer would be 1, -3. So now we're going to look at finding the determinant of a 3 by 3 matrix. And so when you're doing these ones, you'll initially have a matrix that's labeled you could label it as A, B, C, D, E, F, G, I. And this is kind of a general formula for you to follow. But if you can't memorize this, an easy way to look at it as, if we look at A, we're getting rid of the B and the C and the D and G. And so that would be our inside matrix. We're going to go minus. We're going to look at B. We're getting rid of this top row and this middle row. And our matrix would be this and this. So we would have D, F, G, I plus the C. So if we look at C, we get rid of the A and the B, and then the F and the I. And that is our matrix right there. And so it's a lot longer to do, but it can be done. So let's look at solving one of these really quick. So we have this matrices, and we're going to do the first one first. So we're going to look at the A. So if you look at the A, we're getting rid of these two 5s and the 2 and the -4. So we'll have the A being 6. I'm going to write this down to see if it might help you. So if we look at the A, we're getting rid of D, G, and B and C. So we're getting rid of these 5s and these 4s. So our small matrix would be 6, 2, -2, -3. Minus, if we look at B, we're looking at the 2. We're not looking at the A or the C, and we're not even looking at the E or at H. So we have 2, followed by the small matrix of 5, 5, -2, and -3. Plus, when we look at C, we're getting rid of the A, the B, the F, and the I. So when we look at C, we're getting rid of the 6 and the 2, and then the -3, -2. So we'll have -4, followed by the 5, 5, 6, 2. And then you would just follow the 2 by 2 determinants to get to your answer. So we have the small fish, we have our fish. So we would have 6 times -3 minus -2 times 2 minus 2. For the second one, we would have 5 times 3 minus -2 times 5 plus the -4. In the third one, we would have 5 times 2 minus 6 times 5. You'd get 6 times, when you calculate this out, you would get -14 minus 2, this would equal 5, or -5, excuse me, plus the -4, and this last one would equal 20. When you plug that into your calculator, you would get A is equal to 6. So now we're going to look at using the Cramer Rule of a 3 by 3. And so we're going to use the determinant of a 3 by 3 when we're doing these ones. And so we're going to have 3 variables. Typically it will be of an X, Y, Z, then your answer column. And this is the case where I would say I would look at the A, B, C, and D. So you would have A, B, C, and D, and your D would just be your answer column, and you would just look at it this way. So you're going to be given three equations, and you're going to have to write them out as augmentative matrix. Look at the determinant of the coefficients, so the A, B, and C. Then you're going to look at the X matrix. So you're going to replace the answer column for the A column. So this was an A column, but now it's the D column. For Y, you're keeping the A column and the C column, and you're replacing D for the B column. So this was your B column. For the Z matrix, you keep the A in the B column, and you replace the D column in for it. So this was your C column. And then once you get all of those to a certain value, so you'll have a number for the coefficients, you'll have a number for the D of X, you'll have a number for the D of Y, and you'll have a number for the D of Z. You're going to take the D, for example, for the X value, you're going to take the D of X divided by the D. So you're going to go D of X divided by D, and then that'll give you an answer, and that'll be your answer. I would leave them as a fraction if they're going to a decimal, personally. At least then they're more exact. And so I'll do that for each one. And so these can be very long. So we are going to look at this example. And so we're going to write it out as an augmentative matrix first. So you will have for row 1, we'll have 1, 2, 3, and then our answer column or our D column, -5. Then for row 2, we'll have 3, 1, -3, 4. For row 3, we'll have -3, 4, 7, and 7. So this is where I would label it either X, Y, Z answer or A, B, C, and D. So we're first going to do the determinant of our coefficients. So our coefficients being 1, 2, 3, 3, 1, -3, and -3, 4, 7. And then we're going to do the Cramer Rule of a 3x3 to get those answers. So if we look at the 1, we get rid of this first row in the top row, or column 1 in row 1. So we're left with 1, and our matrix 1, 4, -3, 7. Minus, if we look at column 2, we would get rid of these 1 and the 4, and then the 1 and the 3. So we'll have the small matrix of 3, -3, -3, 7. Plus, when we look at the 3, we would get rid of the row 1 and column 3. So we'll have the small matrix of 3, -3, 1, 4. Writing them out, we would get 1, and you would have 1 times 7 minus -3 times 4. Next one, you would get 3 times 7 minus the -3 times -3 plus 3 times 4 minus 1 times negative 3. And that would give you a determinant of, when you do the math, of 40. So now we're going to look at doing the d of x. And so our small matrix would be, so we're keeping the b and the c, and we're replacing the d for the a column. So we'll have negative 5, 4, 7, and then we have the 2, 1, 4, and 3, negative 3, 7. Negative 7, excuse me. So when we write it out, if we look at the negative 5, we get rid of column 1, or row 1 and column 1. So we would have negative 5 being our A, followed by, write this a little bit smaller so I have some room. We would get 1, 4, negative 3, 7. Minus, if we look at the 2, we get rid of row 1, column 2. So we get the small matrix of 4, negative 7, negative 3, 7. Plus, if we look at column 3, we get rid of row 1, column 3. So we would get 4, negative 7, 1, 4. Writing them out, you would get negative 5, followed by 1 times 7, minus negative 3 times 4, minus the 2. You'd get 4 times 7, minus negative 3 times negative 7. Plus, and 3, you would get 4 times 4, minus 1 times negative 7. And plugging that in your calculator, you would find that d of x would equal negative 40. So now we're going to look at our d of y. And I'm going to rewrite our matrix first. So now we're going to look at getting our d of x, or d of y. And so for our d of y, we keep our AC and we're replacing the d for the b column. So we would get the 1, 3, negative 3, the negative 5, 4, negative 7, and 3, negative 3, 7. So if we look at the 1, we get rid of row 1, column 1. So 1, we have a small matrix of 4, negative 7, negative 3, 7. Minus, and then we look at row 1, column 2. So we get the negative 5, and we would have the small matrix of 3, negative 3, negative 3, 7. Plus our C, which in this case is 3. And replace, we would get 3, negative 3, 4, negative 7. Writing this one out, we would get 1, you get 4 times 7, minus -3 times -7 you get 3 times 7 minus -3 times -3 plus 3, you'd get -3 times -7 minus 4 times -3. And your d of y would equal 40. And for d of z, we keep the a in the b column and replace the d for the c column. So we would get 1, 3, -3, 2, 1, 4, -5, 4, -7. So writing this one out, if we look at the 1, we get rid of the 3 and -3, and then we would also get rid of the 2 and -5. So we would have 1, 1, 4, 4, -7. If we look at the 2, we get rid of the 1 and the -5, and then we also get rid of the 1 and the 4. Plus our c, which in this case is -5. And we would get rid of the 1 and the 2, and then the 4 and -7. So our small matrix would be 3, -3, 1, 4. Writing this one out, we have our fishies, or fish. You'd get 1, you get 1 times -7 minus 4 times 4. Then we would get 2, and then we would have 3 times -7 minus 4 times -3 plus -5, and we would get 3 times 4 minus 1 times -3. And d of z would equal 80, -80. So now we have to go through and do, so for x, it would equal d of x over d. So d of x we found was -40, and the determinant we found was 40. So x would equal -1. For y, we found that we would do d of y over d, and the d of y we found was 40. So 40 over 40, and y would equal 1. For z, we found that d of z over d, and so we found that d of z was equal to -80, and the determinant was 40, and so z would equal -2. And if you write it as a pair or as a coordinate point, it would be -1, 1, -2. And that would be your answer. Now we're going to look at solving linear equations. And so now when we're doing these ones, we're going to have a matrix. And we will split the coefficient matrix, so if this was A, from our other matrix, so this would be our variables, so x and y, and then our answers. And so you could think of it x, A, x, and b. And so when we're doing these ones, we're going to follow, so if we have a of x is equal to b, and we want to get what x equals, we would, and find the values, if we multiplied the a of inverse 1 to both sides, you'd get ix is equal to inverse of a times b, and x would equal a inverse 1 over times b. And so that's kind of what we're going to be doing with these ones. So let's look at an example. So for the example, we have this equation, and so we're going to write it in the format similar to the augmented matrix. So you would have our coefficients of 2, -1, 3, and 2. Our variables, so x and y. And our answer being 4 and 13. So we have our a, our x, and our b. So first we're going to look at finding the determinant. So we have the 2, the 1, -1, the 3, and the 2. Doing our fish, you get 2 times 2 minus -1 times 3. And our determinant would equal 7. We're going to do the inverse, so we would keep, or we would switch the A and the D and flip the sign of B and C. So our original matrix of 2, 3, -1, and 2 would be changed to 2, -3, 1, 2. And we have our inverse matrix. So we know we have inverse of 1, and we put our determinant over 1. So we have 1/7, and our new matrix, so 2, -3, 1, and 2. But we still have b, and so we're going to put that on the end. So we can rewrite it, and so we would have our x, our y matrix. We'd have our 1 and 7th, our second matrix, so 2, -3, 1, and 2, and then our B matrix, so 4 and 13. So we're going to multiply these two matrices right here first before we distribute this 1/7 over. And so when you do these ones, so 1 over 7th, you get 2 times 4, plus 1 times 13. Then you would get -3 times 4 plus 2 times 13. And if you remember, we have a 2 by 2 and then a 2 by 1. And so since these middle inside numbers are the same, we can multiply these matrix, and our answer matrix would be a 2 by 1. So when you put that into your calculator, you would get 21 and 14. So now if we distribute out the 1/7. We're not going to have any fractions that we're going to have to deal with. So now 1/21/7 is equal to 3. And 14/7 is equal to 2. And then we still have our x and y matrix. And so our x would equal 3, and our y would equal 2. And that would be it for this one. So now we're going to look at doing row operations. And sometimes you'll see places where, or examples where they're going to have 1 up top. And you can do it that way if you would like. But you're ultimately getting a 0 in this position, and this position. This kind of triangle to get values that you're looking for. And so sometimes you'll have the x, the y, z, your answer. And if you have these first two 0, the x, these two columns being 0, at least then you would have a number times z is equal to an answer, and then you're just going to solve your algebra. So let's look at an example. So we have these equations. We're going to turn it into an augmentative matrix first. So we'll have 2, 3, 1, 1, 4, -5, -1, 2, -2, and 1, 13, 0. So we have our x column, y column, z column, and our answer column. And so for the row operations, we're going to try to get this 3 position to equal 0 first. So you could do multiple. We're going to take 2 times row 2 minus 3 times row 1 and return it to row 2. And so kind of for scratch work, you could do your math over here. If you have your small matrix and we're leaving the bottom row alone, in this case, 2 times 3 is 6. 2 times 4 is 8. 2 times 2 is 4. And 2 times 13 is 26. So 3 times 2 is 6. 3 times 1 is 3. And 3 times -1 is -3. And 3 times 1 is 3. And so since we're going row 2 minus row 1, we keep our top row, 2, 1, -1. And we keep our row 3, so 1, -5, -2, 0, and 1. So 6 minus 6 is 0 for row 2. 8 minus 3 is 5. 4 minus -3 is 7. And 26 minus 3 is 23. So now we're going to try to get this one right here to equal 0. We could do 2 times row 3 minus row 1 and return it to row 3. So row 2 stays the same. So 2 times row 3 and row 1. And we're returning it to row 3. So row 1 stays the same. So we're going to be using this last matrices that we had. So we'll have 2, 1, -1, 1. 2 times 1 is 2. 2 times -5 is 10. Or 2 times -5 is -10, excuse me. 2 times -2 is -4. And 2 times 0 is 0. So row 3 minus row 1. So we keep row 1 and row 2. So 2, 1, -1, 1, 0, 5, 7, and 23. So 2 minus 2 is 1, or 0, excuse me. Negative 10 minus 1 is negative 11. Negative 4 minus negative 1 is negative 3. 0 minus 1 is negative 1. So now we want to get this negative 11 spot to 0. And so we could do 5 times row 3 plus 11 times row 2, and we're going to return it to row 3. So we're keeping row 1, it stays the same. So we're going to go 11 times row 2, and we're going to go 5 times row 3. So if we look at this previous matrices, 5 times 0 is 0. 5 times a negative 11 is negative 55. And 5 times negative 3 is negative 15. And 5 times negative 1 is negative 5. 11 times 0 is 0. 11 times 5 is 55. 11 times 7 is 77. And 11 times 23 is 253. So we're keeping our top row. So 2, 1, negative 1, 1. And we're keeping our second row. So 0, 5, 7, and 23. So we're going row 3 plus row 2. So 0 plus 0 is 0. Negative 55 plus 55 is 0. Negative 55 plus 77 is 62. And negative 5 plus 253 is 248. So now once we're at this step where we have these 3 spots, so we have this triangle of zeros. So we have our x, our y, and our z in our answer column. If we wanted to find the value of z, we could just do 62z equal 248. So 62z equals 248. When you divide 62 by 248 into 248, z would equal 4. So now let's go up a row. So row 2, we don't have anything for x. So we have 5y plus 7z equaling 23. We found that z is 4. So 5y plus 7 times 4 equaling 23. 5y plus 28 equaling 23. Minus 28 from the left side and over to the right. And we would see that y is equal to negative 1. And so for this, go up a row, so for row 1, so 2 times x plus y minus z equaling 1. So we know that the y is negative 1 and the z is 4. So 2x minus 1 minus 4 equaling 1. You'd get 2x minus 5 equaling 1. Add 5 to both sides. You get 2x equal to 6, and x would equal 3. And writing it as a coordinate point, you'd get 3, negative 1, 4. And that would be your answer.